Suppose the prices of milk and gasoline are given in the following table. We have month 1, 2, 3, 4, 5, and 6. M will be milk, so I have $2.99, $3.05, $3.10, $3.07, $3.10, $3.40. And G is the price of gas, say $3.95, $4.08, $4.21, $4.15, $4.17, $4.25. Notice M is going to be a function of T, and we'll call G a function of T. So our input each time to start with will be the month, and then we have two functions. One is the milk function, the other is the gas function. Suppose I wanted to compute F at 4. Well, F at 4 is equal to, well, go up to our table. There's 4. F is our milk function, so we go and we find the output that goes along with that input, so that's 307. So F at 4 is the price of milk in month 4, so F at 4 is $3.07. G at 6. G remembers the gas function, so my input is 6, and I go into the gas function, and I get $4.25. So G at 6 is the price of gas in month 6, so G at 6 is $4.25. Now let's think a little bit backwards. G at what is 408? Well, again, it's the G function, that's the gas function. So what I'm going to do is I'm going to look at the output, right? This will be my output. And I look for my output's 408. And my output's 408 in the gas function in month 2. So what we get is month 2. So what happens is G at 2 is 408. F at what is 310. Similarly, I now go to the F function and I find 310. Notice when I find the 310, however, it appears twice. So in this case, I'm going to get two answers. I'm going to get two answers. The price of milk in what month is $3.10? We'd have 2 months, month 3 and month 5. Notice this is in fact a function, even though we're using this number twice, because our inputs all appear only once. The months are the inputs here, 1, 2, 3, 4, 5, and 6. They appear once, so I do in fact have a function. What does F at 2 equals 305 mean? Well, again, what I know is F is the milk function, the 2 is in months, and the 305 is the price. So hence the price of milk in month 2 is $3.05. Now, our M and G functions, and we basically have talked about this before. They are both functions because each domain element, each input is the month, is matched with only one range element, the price. So we use time only once for each function. Now, here's an interesting question. Is G a function of M? So in other words, is the relationship between gas and milk one that gives us a function? If I'm going to have G as a function of M, then notice the M is the input and the G is the output. So I'll write down the milk prices, I'll write down the gas prices, and to be a function, each M must be matched with only one G. But notice $3.10 as an input is used twice. Since it's matched to both 421 and 417, we do not have a function. Well, how about, is M a function of G? Well, if that's the case, I'd have to have M is a function of G. So our inputs are G and our outputs are M. And to be a function, each G needs to appear only once. And notice in this case it does. Each G is appearing only one time. And so as given, this table is in fact a function.